Bismillahirrahmanirrahim. Assalamu alaikum. Sorry for the abrupt ending there. Again, electricity issues here. Where I'm living, there's a lot of problems with power outages and unscheduled. They're unscheduled, so you can't really, unless you have a UPS or a generator. So where were we? Yeah, we learned about maps, a sock function, dissoc function. Dissoc stands for dissociate, and which removes a key and its value from the hash map. So here we're dissociating distinguish mark from the favorite food, and we get this thing. Okay, let's quickly move on before we get disconnected again.
We'll learn how to access it.
Okay, now there's sets. Again, there are two hash sets and sorted sets. We will probably look at hash sets only. Okay, hash sets are implemented as hash maps with the key and the value of each entry being identical. Got it. The syntax is almost, for example, in hash map we use A1 and B2. So here the key is A and the value is 1, but to define a set we can do this, where now the key is 1 as well as the value is 1. And yeah, set doesn't maintain the order that it was defined in. And we cannot have duplicate entries. Yep. And just like hash map function, there is also a hash set function which creates a hash set or set using these arguments. And we can use the set function to create a hash set from other lists. Now I want to see if this would work here. Yep, it does. So here the set would extract unique values from the provided sequence and only store those. For example, here in the vector there were 2 1s and 2 2s, but in the set that was generated from this vector there's only a single 1 and a single 2. Okay, so to create a sorted set we have to use this function. There's no, for example, there's no syntax like set etc. For example, this would always create a unsorted hash set, and there's no other symbol, for example, doing this or something like this etc., which would create a sorted set. So we'll always have to use the sorted set function. Okay, and another thing, for example, if we define the sorted set on, for example, 1 3 2 4, it would create the set defined by the sortion, or for example which one is bigger and which one is larger, not by how the arguments were given to it. For example, here I gave it 1, 3, 2 and 4, but it would return the set which is 1, 2, 3 and 4. It won't maintain the order that was provided in the arguments. Okay, now we'll just look at some of the functions that are defined over the set. For example, get, we can use the get function to get the value. If it's present, it would return the value, and if it's not present, it would return nil. Similarly, we can check to see if a function contains certain value, if a sequence contains a certain value. If it does contain, it would return true, and if it doesn't, then it would return false. Okay, so for example, if a set contains nil and 1, 2 and 3, and we want to get, for example, from the previous set, we want to get the value nil, then it would return nil. So we are not sure if it contained nil or if it didn't, but if we use contains and then check for nil, then it would either return true or false depending on if the set contained the nil or not. Yeah, we can use it as a function as well. See if the value was, if they contain some value. For example, here I'll try to see if it contained, let's 1. Yep, it did. And can we do it the other way around? I want to see if the set contained, yep, it did. Doesn't work the other way around, like hash maps. And to add an entry to the set, we use the conjoin method, conj, represented by conj, conjoin, which adds another element to the set. And we can add multiple elements, items, using this conj function. And to disjoin or remove an element from the sequence, we can use the disjoint function. Now we'll see what vectors are and how, and what are some of the operations that are defined in these vectors. We know about all of this already. For example, how to create a vector and how to use the vector function to create a vector, and how to convert another sequence into a vector. So there's get. For example, we want to get the value 0, or we want to get the index 0 of this sequence using the index. We want to get the index 2 of this sequence, and if the index is greater than the sequence length, then it would return nil. So let's quickly define a Fibonacci sequence, and then we can perform multiple operations in it. For example, just like before, Fibonacci, and we can get a certain index using this, using the sequence name as a function, and we can add or conjoin other elements to the sequence like so, and they will be inserted in order at the end. Okay, here we're dynamically computing the Fibonacci elements to be inserted. So first we define a size variable or symbol which takes the value of count Fibonacci. It counts the Fibonacci elements and saves the result in the size symbol. Then we get the last number by calling the last function on this Fibonacci sequence, and then we get the second to last number by calling the Fibonacci and size -2, which would get us the last index, and we're using the function as a sequence as a function to get the value stored at this index. That's the second to last number, and then we'll conjoin to the Fibonacci sequence by adding the last number and second to last number. So this would give us 5 plus 8 is 13. And now there are lists. I wonder after there's list, then sequence abstractions, and then working with nested data structure, and then activity. Yep, cool. Okay, lists. Yeah, we know about this already. In vector, items are added at the end, but in list, items are added at the front because it's faster to access the first element in a linked list. So lists are defined, and the underlying data structure that the lists are using is a linked list. And we use these parentheses to define a list. And to differentiate lists that represent code and lists that represent data, we need to use the single quote to differentiate it. For example, here it's thinking that it's a coding list. For example, here it's using the same symbol, for example open parenthesis, and then there's a function name, and it would treat it as a code. But here if we want to treat it as a data, then we need to add single quote as before it, so it would be treated as a data. Then here it's not evaluating it, it's treating it as a data. And we can use the list function to create a list. Yep, first would give us the first element in the list, and the rest would give us the all elements except the first. Similarly, next would also give us all elements except the first, the only difference being that in case of, for example, a single, if a set only contains a single element, then rest would return empty string, while next would return nil. So rest by default returns a truthy value, while next would return a falsy value. And we can also use the nth function as well to get a index, to get a value at a specific index. It should behave exactly the same way. For example, I want to get this value, and we can also use get as well. For example, 1 2 3 and 10. Okay, so get doesn't work really. Oh yeah, get is, for example, for things like hash map and vectors, where we can quickly go to the specific index, while nth is, for example, here we have to iterate to the second index. First it would go to the first and then it would go to the second. For example, it can't really jump to a specific index. It have to go through all of these elements before reaching the nth index. Okay, you can add items to your list by using the cons function, which operates on sequences. Cons stands for doc cons. I don't know what cons stands for. You can use the conj function, which is used because a list is a collection. Conj by conjoin a new item to the list. For example, go to work, it would be added to the front. Similarly here, it would be added to the front as well. Go to work. Okay. So in cons, we have to first provide the item that needs to be inserted into the list. So first there's the item and then the lists. In cons, first there's the sequence or list, then there's the item. So cons is available on lists because list is a sequence. Yep. And conj is available to use on list because a list is a collection. Conj is conjoining, is therefore slightly more generic and also has the advantage of accepting multiple elements as arguments. Okay. Collections and sequence abstractions. Okay, a sequence is a collection of elements in a particular order where each item follows another. So in sequence the order would be maintained, for example, like in lists and vectors. So lists and vectors are sequences, while maps and sets are considered to be collections. Okay, we can use the count function to get the number of elements in a collection or sequence. And we can see if a collection is empty or not. And we can convert a map to a sequence using the sec language, using the sec function, sequence function. So it would create a vector where the first element of the vector is the key and the second element is the vector, is the value, and then it would store it in a list. Okay, we can call first directly on the sequence as well, on the collection as well. Okay, by using into, we can put element of one collection into another collection. For example, here we want to put the element of the second collection 5 6 7 8 into the first collection. The second collection is a set and the first collection is a vector, so we can add elements from one collection into another. Similarly, we can also add from a vector into a set. Yeah, if we want to deduplicate or remove the duplicates from a vector, we can add it into a set, and then we can either convert it into a vector as if we want to later on, but this would remove the duplicates from the set. And to put items into a map, we have to provide a vector containing a list of vectors where each vector inside would contain a key value pair. Okay, they're calling it tuples. So is it a tuple or is it a vector? Yeah, it's a vector. Okay. So into works by conjoining each of the element in the collection. So for example, here if we want to insert elements from a vector into a list, then the following would be done. For example, first it would conjoin an empty list with the first element 1, and then it would add 2 into this element, and then it would add 3, and yeah, so at the end it would be 4, 3, 2 and 1. And then there's a concat function which concatenates two collections. For example, here 1 2 3 4, it would concatenate it as 1 2 and 3 4, but in into it would be 4 3 and 1 2. And concat would always return a sequence no matter what the arguments were. For example, here it's a collection, not a sequence, because it's not ordered, and the resulting the output of concat is still a sequence. And we can use the sort function to sort a sequence or a collection. Okay, we can sort it into a sequence, and then we can use the into function to get a vector, or we can use the vec function to convert it back into a sequence, into a vector, I mean. Yeah, similarly, a vector is an associative collection of key value pairs where key is the index of the value. So for example, we can use the sort function, which was defined, which we learned about, was defined for the hash map. So we can append or associate the index 2 with the value z. So a, b and c would be replaced with z, and then d. I just want to see if we need to use our editor for this code editor, or is the REPL fine? Okay, let's just quickly go through this. A pure function is a function where the return value is only determined by its input values. A pure function does not have any side effects, which means that it does not mutate a program's state, nor generate any kind of IO. Okay, so it only works on its input arguments. Got it. So here we're defining a gemstone database, and we can't copy it as it is because it's copying these lines as well, line numbers as well. So we'll have to type it in. or we can use this. So yeah, let's just just copy paste it. Let's just copy paste it, paste in the UI. So we've defined what is this, a map, a hash map, and assigned it or bound it to the gemstone DB. So where the first key is Ruby and it contains a hash map as well. The second is diamond, which also contains a hash map containing some information about this key, and we also have another key as well. So Ruby, which contains key value pair, okay, this contains another nested vector inside it, and this has another nested map, and this contains a vector. So multiple hierarchies of data. Okay, so we need to find if a gem is hard enough or what its hardness property. We will define a function called durability, which would get this hardness property of a key. For example here, if we want to see the hardness of Ruby, we first have to go into Ruby key and then in the properties, and then there's hardness. So to do that, let's evaluate it from inside out. First it would get the gemstone DB, but first it would get the Ruby key from the gemstone DB. So it would get the value of the Ruby key from this sequence, which would return, for example, this sequence, and then we would call get properties on this sequence. So it would also return a sequence, and then it would also return this sequence, and then we will get the hardness from this sequence, and it will return 9.0. For example here, let me just copy paste it. So yeah, it would return 9.0. It would go first, it would give us the value of this key, which is this value, and then it would give us the value of properties, and then it would give us the value of hardness. And instead of doing this get and key name, we can use the other syntax that we learned about. For example, specifying the key name as a function. For example, here we're getting the Ruby from the gemstone DB, and then we're getting the properties and then hardness. Okay, now we'll learn about another function called getIn, which works with nested maps well. So to call it, we would call the getIn function on the gemstone DB and give it these keys. So first it would go into Ruby and then properties and then hardness, and it would return the value. And we can define the durability function such that it first argument is the database and second argument is the gemstone that it needs to find the durability of, and then we can call getIn on the database and get the gemstone and its property and hardness. So now we need to change the property, more specifically change the color of a gem, and we want to return the updated database. So first we will try to use the assoc function, which associates if the value is already present, if it updates it, and if it's not present, it adds the value to the database. So we want to assoc to the Ruby in the gemstone DB properties, and we want to change the color to this string, and it returns this updated color. But the thing is that all the other properties which were, for example, here we can see there are other properties: dispersion, hardness, refractive index, and color. All other properties have vanished. Okay, so instead of using assoc, we will try to use the update function. Yeah, update works better. For example, we'll try to use update on the Ruby gemstone DB, and we want to update the properties into, for example, here we're defining the new color. Okay, so nkf, k is a key and f is a function that will take the old value. Okay, so into would take the old value of these properties, and then we'll add this function, this updated color, into it, and it would return the updated value. Okay, we can use assoc in, just like get in. Assoc in also works with nested data structures. So we call assoc in on the gemstone database and pass it these keys. For example, first is Ruby, and then properties, and then color, and we want to change it to this new value. So at the end it would return the whole database instead of just returning the Ruby. Okay, so there's also this function called prettyprint. Which word? For example, let's just quickly call it. Yeah, it's not very readable, but we can prettyprint the last output, and yep, this is, and we can see the color is updated successfully. And we will define a new function change color, which would take 3 arguments: the database, the gemstone, and the new color. So we will call assoc in with on the gemstone database. It should not be gemstone dash database here, I guess it should be just db, right? I guess it's a typo. Yeah, it should call on just db, and then we want to go through this like gemstone, and then properties, and then color, and we want to assign the new color to it. Okay, now we need to create a function that would, for example, when a sale occurs, it would add client ID to the sales vector and decrement the stock value by 1. So we'll try to use the update in and call on the gemstone database, where, for example, here we're trying on diamond and then their stock, and then we decrement it by 1. So where's the diamond in stock is 9 now, but before it was 10, so it's working. Okay, use the print level function to set the data level to 2. Observe how the result is printed. So we can set the print level to 2 depth and then see how the result will be printed. Yeah, it's not printing the properties. And now we need to use the updating function to add our client ID to the sales vector. So update in gemstone database. We're working on diamonds and its sales value. For example, yeah, here's the sales, which is currently not being shown because we've set the print level to 2. So here we want to append or add another a client ID to this sales vector. So what we do is sales and then conjoin the new ID to it, and we need to set it nil again to see if it was inserted or not, because currently we can't see if the value was inserted. So in the diamond and sales, is there a 999? Yes, there's a 999. And now we will define our sell function, which would combine the previous 2 expressions. So it would take a DB and a gemstone and a client ID. Now we'll define a client's updated database. For example, by update in database gemstone sales and conjoining the client ID to it, it would return the newly created database or newly updated database to this client's updated database, and then we would update in that client's updated database and decrement the stock by 1 and return this updated database. Okay, so it's activity time. Yep, I love those. So we'll create a new file. So we'll just first let's go through the statement. In this activity, we are going to create our own implementation of an in-memory database. After all, if the sparkling shop owner was able to do it, then it shouldn't be a problem for us. Our database interface will live in the Clojure wrapper. We will implement functions to create and drop tables, as well as to insert and read records. For the purpose of this activity, we will provide a couple of helper functions to help you maintain the state of database in memory. First is MemoryDB. There is something called atom and empty database, then def1 read db, which doesn't take any argument and returns memory db, and then ref1 write db, which takes a new db and we set memory db to new db. Okay, so you can use these functions to act as in memory database. For example, this atom would give us a in memory database, and then we can call read db to read that database and write db to update that database. Okay, so let's quickly create a new file, save it inside chapter 2 and name it activity 2.01 and in memory db.clj. So first let's just copy these functions which were predefined for us, and then for the sake of, should I copy this? Okay, let's just quickly go through this. So here, for example, this is the data and these are the indexes. For example, index on id 1 is at index 0 and id 2 is at index 1. Similarly here, name, the name lemon is at index 0 and the name coconut is at index 1, and here similarly id is 1 at 0 and 2 at 1. Here the helper functions, you can get the hash map by executing read db function with no arguments and write to the database by execute the write db function with a hash map as an argument. Start by creating the create table function. This function should take one parameter, the table name. It should add a new key, the table name, at the root of our hash map database, and the values should be another hash map containing 2 entries, an empty vector at the data key and an empty hash map at the indexes key. Okay, so we'll define a function called create table, which takes as an argument, this function take one parameter, table name, and it should return add a new key, the table name, at the root of our hash map database. Okay, so we want to okay, this is going to be difficult. Read db, what would read db give us? First let me just see how this works in the REPL, just anyway. And if I want to read database read db, it would return as empty hash map, and if I want to write db takes a new database So for example, let's say I want to update the old database, for example by calling readDB and then passing it this new value, table name, and table name with an empty this, and we can use add data and an empty list and indexes and an empty map. And let's just okay, class DTB cannot cast to Clojure.lang.associative. Weren't we using a sock to update a map? A sock, database name and new values. For example, there was using maps. A sock function returns a new map containing a previous key value. Sock favorite fruit, new value. So here we want to assign this table name, indexes, close it. It should work. Okay, let's just, instead of doing all this, we just simply, how about simply return this. Class readDB cannot be cast to class Clojure.lang.associative. Sock empty database, and we want to add table name and an empty database to it. Yep, it's working here, but it's not able to convert. Oh, sorry. Yep, it's not a, we have to call it, this is a function read database. So now it's returning a table name, and where's the table name? This would be the table name, and a map which contains a data which can contain other, which is of type which contains the value of vectors, and another called indexes. I think this will work fine. So let's copy it and we'll paste it here. Remove the extra. Okay, so here we want to use the table name. It would write DB and associate readDB table name and returners this create table function. So let's quickly test this. Just anyway, and create table and did I not update it? Oh, why is it not working? Where's the table name here instead of, let's just quickly change it to name, and let's just change this to name, and again copy paste it, paste anyway, and try calling create table on clients. Maybe because yeah, created, okay, it was table name was coming from here. So how to reset the database? For example, I want to write db and this is the new value. Okay, and now if we create a client's database, yeah, it would work fine. And to remove a table, I guess we can simply copy paste it, and here we'll say drop table, and instead of associated we can dissoc, and with database name, and we don't need to specify this. It would simply so if we let's say take a look at our read database. Okay, our read database, it contains a clients table, and we can drop table if we pass in remove a table. Yep. So yeah, it drops the table name, and now if we read the DB, it's empty. Okay, so now we have to create an insert function. So define insert, which takes 3 parameters: table, record, and id key, and we would, the record parameter is a hash map, and id key corresponds to a key in the record map that will be used as a unique index. For now, we will not handle cases where a table does not exist or when an index already exists in a given table. And we'll use a let block. What's the problem here? Redundant let expression. Here they used a let block somewhere here, I guess, at the end. How is it redundant? Okay, anyway, this would define a let block, and here it would be the statements. So let block, try to use a let block to divide the work of the insert function in multiple steps. In a let statement, create a binding for the value of the database retrieved with readDB. Okay, so we can create the binding let db is equal to readDB. That's how that works, right? And it's updated db readDB. Yep. And then we can define another updated database. In the same let statement, create a second binding for the new value of the database after adding the record in the data vector. Updated db, it would be after adding the record in the data vector. So we need to add the record into the data vector of the table. Okay, so do that. Done. We need to use update in, I guess, update in database. Here it would be the table name and then data, and then we want to conjoin this. Yep, this will work. So we can use update in, and we can, for example, what's the problem here? Okay, control Z, just one. Updated in, so we want to update the current database. We want to use the table name, and then we want to use the data, and we want to conjoin the record to this database. Okay, let me quickly do that. And then this will return as the updated database. Retrieve the index at which the record was inserted by counting the number of elements in the data vector. So get the insert index it should be count of what was the best way to use the get function instead of, for example, get in. So we can use get in updated db, and we want to get that table, then data or data. So this would return the data vector, and we would count it and insert the index. But because it's zero based, we also need to use dec on it. So decrement it by 1, and it would be the insertion index, insert index. and in the body we would update the index at id key and write the resulting map to the database with write db. So to update it we can use, simply we use the blue one. So we'll write db assoc and root db, and we'll give it not name here, it would be table, and no assoc in, I guess it should be assoc in, and let's bring it on the line so it's easier to read. And so we want to write the database. Okay, where was, in the body of the let statement, update the index at id key and write the resulting map to the id key. So here we'll go into the index and then updated the index for this to be, so for example 1 0 to 1, it's 1 0 to 1. So we don't need to decrement it here because we can use id key. This is the id key and this would be the index. Okay, got it. So we need to assoc in. How does assoc in work? Let's just quickly revise that. Where was assoc in? Assoc in gemstone db ruby. So assoc in read database, and then here we would provide control z we provide for example table assoc in. It shouldn't be read db, it should be updated db table, and then indexes, and then the no, it's not assoc in, we want to add to it. So where was the sales one? Updating, yes, sales one. So updating updated db, we provided the table, and then the indexes. Here it's sales, let's kindly updating db indexes, and then we want to conjoin instead of this, we want to conjoin, is it conjoin? I guess so. So conjoin the id key and the insert index. Sure, hopefully this would work. So paste anyway. So first let me just quickly see if it is working as expected. Okay, first let's read the db and see if there's anything present. Nope, there isn't. So we'll create a table named lines, it would return us this, and then we can insert a record. For example, insert, what is the table? Table is clients. What is the record? Let's just use something from here, but instead of adding, okay, yeah, we can do this. Insert clients. What is the record? This is the record, and id key is id, and execution error. Don't know how to create isaac from clojure.lang.keyword repo 6. Don't know how to create isaac. I guess because we're conjoining the record. Updated db, update in db table.data, conjoining record. Don't know how to create isaac. What is the keyword here? This is the keyword here. Okay, so what could be the problem here? We're passing in the table, passing in the record, and let's just quickly see if we can conjoin a record like this. So conjoin this and this. Now we don't want to conjoin it to it, we want to add it to a vector, and yep, it's working this fine, so there's no problem here, I guess. Insert index should also work fine. I think the problem is in so here we want to update in updated db. We go to the table and then indexes, which is empty, and we want to conjoin id key, and we should get the value of the id key as well, I guess. I don't know, it's a little bit. For example, create table fruits, insert fruit name, name pair, record with name pair reporting. Insert fruits this and id. So instead of, I guess we're messing it up here. Let's try what we're doing here, conjoining to an empty string. Nope. We need to conjoin to a key. This should be the, yeah, we need to conjoin add this, and here we should conjoin different things. So we also need this name as well as this lemon, and we have to get it as well as the index. So we can call it on the record. Yeah. So instead of conjoining id key, how about first we conjoin the id key and this. When we do that, for example, if there's empty, then we can id and this, we conjoin that. Maps, there's get, there's a sock, there's update. Conjoin doesn't work with, let me just quickly see. So a sock id and this, yeah, it would, yeah, let's first change it to a sock id key, insert index id key, and here we should return a new example sock id key. But what if there's also an id here, for example a1, and we want to update it and we add b2 here? Unmatched delimiter. Where's the unmatched delimiter? Yep, here it is. So it would update it. But how about if we use a sock in? Not a sock in. How about if we use update? id is null. How about if we use update in? Nope. So we want to preserve the previous. Where's the update in? A sock in or update in? A sock in. A sock in. Where is this? A sock in. A sock in the db, which is empty for now, the key, which should be id, and the new value, which should be something, for example b2. So it's working. But what if the current db also contains a value, for example a1, and then we need to close this as well, and nope. It's not working. Okay, soak in. How about updating? Nope. What do we want? How about we get the old value and append it? So here, token ID, this is the original. So how about if we go to ID and then we change it to B2. How about what if we don't change it like that? What if we call a function? But this was not. What if we sock it? Nope. No. It's harder than expected. So the problem here is that we need to add the index key. For example, here the index key would be ID, and we need to update it and add further and further keys here. First time there won't be any ID defined, so when the first data is inserted, this would be created as well and a new entry would be added. But after that, we should update this entry instead of. Yeah, how about so it's updating the ID instead of appending to it. So what were other functions? This sock, update, so we can use wait a minute, where was the update? And we should where was the update in function defined? You would use update when you want to update a DB name within a function. So if we where was the updating? Token update into, we can use into as well, but isn't there some better way? Update in, so here we want to example update in id, and at id we want to sock v2 updated id, and id we want to sock b2. Yep, finally we figured it out. So but what if there's no id? What if it's empty? Then it would still work. Yep, we figured it out, ladies and gentlemen. So instead of this we can use this, Control Z. We can use this update in. Here it should be the updated database, and we want to go into the table. For example, here we want to go into the table, and then we want to go into the indexes, and then we want to go into the id, and there we want to associate the record, for example record, and id key. It would get the value. Do we need the value? For example, what do we need here? We want to associate the id. For example, here the id was 1, so yeah, id was 1. We want to associate that id. What do we do here? Yeah, this would get us an id, and we want to associate it with index, insert index, and this should work. Let's hope that it does. So our current database is gdb, it's empty, so we insert. For example, where was the insert? Just insert. Okay, yeah. So we insert a clients, we insert into clients a data of id1, name Bob is 30, indexes is id1 and 0. So if we pretty print it, pretty print *1, we get this id1, name, indexes id. Okay, it's not very pretty, I guess. Anyways, so let's add a couple of, let's add this as well. So we want to insert into the clients, and we want to insert this record, and the id key is id, and it should appended clients data. There's id1, name Bob is 30, id2, name Aleph is 24, indexes is on id 1021. Perfect. Okay, so now we've done with create table version, drop table version, and insert. Create a select-star function that will return all the records of a table passed as a parameter. What? Select star. Oops. It should return all the records. Okay. Name. Got it. So let's create another function called select-star. It should take as an argument table name, and it should simply return all the records present in the table. So we can I guess call get in table and data. Isn't that how get in works? Where was get in defined? Get in, yeah, first we have to read the database, read DB, and the values we want to get. Yep. So select star and Control C and Control V, paste anyway, and we can call select star on our client's database, and it should return all the records. Okay, so now we'll create a function called select dash star dash where. Where it would take table name. Let's call it table name, or yeah, let's just call it table, and it would take a field and a field value. Okay, the function should use the index map to retrieve the index of the record in the data vector and return the element. The function should use the index map to retrieve the index of the record in the data vector and return the element. Got it. So here we want to return, for example, it should I use let blocks, etc. For example, first it would need to go to the field, which is the index key, and if the field value is equal to here it's multiple get in, we would use get in to go there. We will return get the index. Let's just create a let block, let index is equal to get in read database, and we want to go to the table indexes of field, and then we can also go to the field value, I guess. For example, here, we'll go to indexes, then field, and then field value, and get the value. Yeah. So field value as well. Unused binding, but we are using it. Oh yeah, it's not field. And then we can simply return the we can also use the read db, we can also use the db as well here, for example here. So we just read the database once, db, and then we can call db, we can call get db, or simply db and index. So this should work. Paste anyway. Where was the example? So select star where id, yeah, let's just read db and select dash start dash where. First we give it the table name clients, then we give it a field. For example, here it was ID, and then we give it the field value, and I want the first record, so it's returning nil. Okay, and just to quickly see if, for example, 1 2 3 and 1 will return 2. Yeah, this syntax is correct. The db, no, it's not db, it should be, yeah, it should be db database data. My bad, it's not db. First we need to get into db, and should I use get in or, okay, let's just use get in db table data. So get into that, and then we simply return the index of that data. Control C, Control V, Control paste anyway, and we can select, yep, so select dash where is also working. Modify the insert function to reject any index duplicate. When a record with ID key already exists in the indexes map, we should not modify the database and print an error message to the user. On completing the activity, the output should be similar to this. Okay, so now we need to reject if the, what is already present, ID key, where am I using ID key? Let me just quickly toggle wrap, and okay, so instead of writing to the database, we can use an if else block here. Yeah, let's just use that. Okay, let's just wrap it in and then if block, what is the condition? Okay, here it would be the condition, then if the condition is true, and here if the condition is false. So if it doesn't contain it, then we would do this. If it does contain it, then we would simply print line. Okay, record with name already exists, aborting record with did we use string for that? Yeah, let's just example, let's create a string function, string record with, and we can break it here, and here it should be record, and again another space, and here it should be record with Control Z, record with name peer. Okay, from where did I get updated DB table index ID sock record ID? So already exists. Aborting. Okay, now what should be the condition? So to check if it already exists, we can either use the let block to calculate that, or should we use the let block? Let block exists. Get in and will return nil, so we can use get in here, get in db, if get in db, and we can get the table. For example, here we're going then indexes and then id key and then that should be id key and then record id key. Then that's getting out of hand. Control Z, Control C, Control V, paste anyway. So if we do read, okay, it's if we read db, then there's data id 1. How about if we add another element? For example, if we try to insert, let's just write it ourselves, insert into clients new record with id 1 name id, oh sorry, it should be id 1 name Adam, and calling it on this, then it shouldn't have included it, right? And 1 2 2 1, yep. So our if condition is false, if get in db this, if what is the not to false, yeah, we should make it not getting. And here we would use all the getting inside of this. Paste anyway, and let's just quickly insert record with id 1 name Adam 1 already exists, aborting, and it's returning no. It should not return no. Yeah, instead of printing we can simply return the string. Okay, this is way too, we can separate it into separate lines, print line instead of using print line, we can use this if this is the condition and a record with name, where we can use id key. So now it should work relatively better. Record with id1 already exists, aborting, working. So but if we change the id to 4, it's also working. This id1 and this id1 is there because of the bug before, but now it won't insert duplicate IDs. Okay, so I guess we're done with this. We'll take a quick look at their solution as well. Let's see if they have a solution. In this lesson, we discovered the concept of immutability. We learned about Clojure's simple data types as well as their implementation on different host platforms. We discovered the most common types of collections and sequences, maps, sets, vectors, and lists. We saw how to use them with generic collections and sequence operations. We learned how to read and update complex structures of nested collections. We also learned about the standard functions for using collection data structures as well as more advanced usage with deeply nested data structures. Okay. Complete and continue. So activity 2.0.1 and continue. So let's just compare our solution with theirs. Create table table name, write db assoc. So they use let here. I just call it here and cut the value that way. Otherwise it's almost exactly the same thing. Then we do the it's almost the same except that they use let block to define db and I just simply call read db here. Okay, now insert table name, record, id key, let db, read db, updated db or new db, updating db, table name, data, cons, record. This is same index. We -1, I use decrement, count, get in, new db, updated db, table name, data. So it's same. And write db, just will focus on this as they defined it again later on, but okay. So write db here, this is the updated function which doesn't add the duplicate IDs, but this is the one which does allow duplicate IDs, and the one which doesn't allow duplicate IDs is the one below this. Okay, so we'll just look at this. Write db, update in, updated db, table name, index is id, and then we use a sock on that, record id key, record id key, same thing, and then insert index or index. Yep, it's also the same. Now let's look at the select table name, get in, read db, table name, data. It's same. Select where, table, field value, let db, read db, index, get in, database, table name, indexes, field view, same. And they also use data. For example, here I'm using this right here, and yeah, it's almost the same. Now let's look at this one. So table name, record id key, if let. Okay, now this is a new keyword, if let. I haven't learned about this before. So doc if let. Okay, it's a clojure.core bindings then else and old form. Okay, if something is probably, if test is true, evaluates then with binding form bound to the value of test. If not, yields else. Let's try to see if we can figure out from this. If let existing record select where table name id key record. Okay, we're using the selector function. Okay. If let existing record select where, we're calling this function, table name using this one, id key using this one, and id key record. So we're passing in select to this select where and printline string record with. If this is not null or if this is not false, then, or if this is false, existing record exists, or if this is true, then it would do this, else it would do that. Got it? Else it would do this. Okay. If let existing record select dash where table name id key record. If this is true, then string record with id key and id key record already exists about ink, and they used print line. But in the index they weren't showing the nil. Anyways, otherwise it's the same as this one. Yeah, it's completely identical, these two blocks. The only thing they added was this, and I used if here. So the problem with this is that I will still calculate all of that, and then yeah, let's try to use if let here. That way we'll also learn new thing as well. So if let, if dash let, and then there's this and this. So if let this and then this and then let lock. Okay, if let exists exists okay, if let exists, we will call select where with table and id key and record id key. If it exists, then don't close this, need to close it here and not here. I need to close it here, and then we form this. So instead of where was, yep, we'll simply return this row v. Okay, so let should it be above this or below this? I don't know if the order matters in this. I guess it does matter here. So let's just quickly paste it here. Yeah. Okay, if let missing else branch, if let and we need to add one here. This is the true branch and this is the false branch. Missing else branch. Now control V. We don't need else branch in this case, I guess. Let's try this, or let me just, for example, remove this from here and remove this from there and just write it like so. Write db updating sock record if let exists, and if we paste it and then try to insert, it is inserting. But it should not insert if let exists, and then we're calling this function. Okay, and then we're calling string already exists, aborting. So yeah, it should be the else block. Yep, this is the if block, this is the true block, and this is the else block. So it should work fine now. Yep, record with id1 already exists, aborting. And if we add a different id, let's say 6, then okay, key must be integer. Execution error. Let that start. Where? This was working and this isn't. It must be integer. Table id key and record id key. Again, let's try this. This works, and if we change it to 2, it will also exist. We change it to 3, then it most probably this. Let tv read tv. Okay, this is strange. Flag dash where table id key record id key. So table name indexes field value, it's the same as there. Data get in db table data, and we're getting the index. So get in, it should return false if the data isn't present, right? Yeah. So what's the problem then? The key should be an integer illegal argument exception at user select where key must be integer. What key? Okay, it's messages, error messages aren't very clear. Okay, so yeah, most probably the fault is that instead of getting db table data, and then probably the index is also false or nil. What if we, for example, call get on a nil index, where it would return nil? So most probably if we, but what if we used this instead? Yep, that's there. So we need to use get, and just like there we can move the get in part up a little bit. For example, here it should be table and data, and we can simply use data here. So this should work now. Control C and Control V, and now if we try to insert column, it would insert it, and if we insert it again, it won't insert it. But changing to 4 already exists, 5 inserts it, so yeah, it's working fine now. Yay! That was difficult and took a lot of time, but still we learned a lot about how this works. Still, I don't really like this syntax seems too confusing to me, or too mixed up. It's not pretty printing as well. It should format it. Control Alt F, Control S, Control Alt, Control Alt F. Format document, Shift Alt F, Shift Alt F, Control Finish. So it's formatting. Okay, yeah, it's fine. Shift Alt F, Control S. I guess that's it for today. Or should we? Yeah, this would be too much for now. I guess we're done for today. Should we solve a couple of foreclosure problems as well, or should we just call it a day?